For problem 5.44, draw the shear and bending moment diagrams for the beam and loading shown and determine the maximum absolute value of the shear and determine the maximum absolute value of the bending moment. First, from the figure, we have to draw a free body diagram, and from the free body diagram, we can get the force at E and D, which is 3 kN times 0.9 meter equal to 2.7 kN meter. After that, we have to find the moment at B, which is equal to 0, and from the equation, we can find the direction at A, which is equal to 6.75 kN with upward direction, and B, and direction at B, which is equal to 6.75 kN with upward direction too. Next, we have to find the area of load diagram, which is from A to C, and 3.5 kN per meter times 2.4 meter, which is equal to 8.4 kN. And area of load diagram from C to B, 3.5 kN per meter times 0.6 meter, which is equal to 2.1 kN. For the shear diagram, we can find the shear force at A, which is equal to 6.75 kN. Shear force at BC equal to 6.75 kN minus 8.4 kN equal to negative 1.65 kN. And for the shear force at C positive is equal to negative 1.65 kN minus 3 kN equal to negative 4.65 kN. Next, for the shear force at B equal to negative 4.65 kN minus 2.1 kN equal to negative 6.75 kN. Over A to C, shear force equal to 6.75 kN minus 3.5x, and at G, shear force is equal to 6.75 kN minus 3.5x at G, which is equal to 0, and xg is equal to 1.92 x 6 meter. For area of shear diagram from A to G, from the formula, we can find and after substitute the value, the answer is 6.5089 kN meter. And from G to C, after substitute the value into the formula, the answer is negative 0.3889 kN meter. And C to B, the answer is negative 3.42 kN meter. Next, we can find the bending moments. Bending moments at A is equal to 0. Bending moments at G is equal to 0 plus 6.5089, which is equal to 6.5089 kN meter. And bending moment at C negative is equal to 6.5089 minus 0.3889 equal to 6.12 kN meter. And bending moment at C positive is equal to 6.12 minus 2.7 equal to 3.42 kN meter. And bending moment at B equal to 3.42 minus 3.42, which is equal to 0. And the final answer for question A, which is maximum shear force, is equal to 6.75 kN. And for the question B, which is maximum bending moments, is equal to 6.51 kN meter. For the question 5.79, 2L102 times 76 rolled steel angles are bolted together and used to support the loading shown. Knowing that the allowable normal stress for the steel used is 140 megapascal, determine the minimum angle thickness that can be used. And from the figure, we have to draw a free body diagram, and from the free body diagram, we can find the moment at A, which is equal to 0, and from the equation, we can find the reaction at C, which is equal to 4.5 kilonewton with upward direction. And from the free body diagram too, we can find the force of X component, which is equal to 0, and finally we get the reaction at A, X is equal to 0, and force of Y component equal to 0, and we get the force at AY equal to 4.5 kilonewton with upward direction. Next, we have to find shear force at A, which is shear force at A equal to reaction at AY, and the answer is equal to 4.5 kilonewton. And for the shear force at C is equal to negative 9 kilonewton plus 4.5 kilonewton and equal to negative 4.5 kilonewton. And from the shear force diagram, we can find the maximum bending moment, which is equal to 4.5 kilonewton meter. And after substitute the value of maximum bending moment and the normal stress, we can find the minimum angle thickness that can be used, which is equal to 32.1 times 10 the power of 3 millimeter cube.